Next, let's run a trial simulation. First, open the Teach pendant, go to the menu, select I/O, and choose Digital to ensure that all DOS are in the off state. Close the Teach pendant. Next, click the Main Program Main, open the Run panel from the top menu, and click the Run button. During the simulation, we noticed that the stereoscopic warehouse module and positioner module's assembly position still had a joint finished product. This is an error. We haven't performed the assembly yet. This error is due to a visibility issue. After grabbing the joint finished product, the joint finished product in the positioner module's assembly position still exists, which is also a visibility problem. Now, let's resolve this visibility issue. First, in the left menu bar, under the Fixtures directory, find the stereoscopic warehouse module, right-click, and select Properties. In the Parts tab, click Joint Finished Product and uncheck Visible at Runtime. Click Apply. Then, in the left menu bar, find the positioner shaft under the Machines directory, right-click and select Properties. Open the Parts tab. Similarly, in the Parts tab, uncheck Visible at Runtime for Joint Base, Joint Finished Product, Motor Finished Product, and Reducer. Now let's run the simulation again. This time, we find that these objects no longer exist during the simulation. Finally, there is one more issue. After removing the joint finished product, a joint finished product still exists in the positioner shaft. This is because this joint finished product is from a previous assembly. To solve this, we need to remove these parts when the robot grabs the joint finished product. In the simulation, under the Machines directory, find the positioner shaft, right-click, and select Properties. Open the Simulation tab and uncheck Allow Part to be picked for Joint Base, Motor Finished Product, and Reducer. Also, under allow part to be placed, there is a destroy delay, which defines how long the part will remain before being destroyed. After calculating based on the simulation time, we determined that the joint base should remain for 35 seconds, the motor finished product for 15 seconds, and the reducer for 10 seconds. We confirm that the joint base should not be picked up, it will remain for 35 seconds, the joint finished product is unchanged, the motor finished product should not be picked up, it will remain for 15 seconds, and the reducer should not be picked up, it will remain for 10 seconds. After completing these settings, we restore the signals and run the simulation. This concludes the content of Assembly Workstation Simulation Programming. This concludes the content of Assembly Workstation Simulation Programming. Through this lesson, we have gained an in-depth understanding of the basic steps and techniques involved in Assembly Workstation Simulation Programming. From the grabbing and assembly of individual parts to the picking and storing of joint finished products, and editing the master program, we have mastered the entire process of simulation programming. What we completed today is not just assembly workstation simulation, but also a digital submerged tunnel docking. The builders of the Hong Kong, Zhuhai, Macau Bridge have created a world miracle with an attitude of only one from start to finish, while practicing the quality-first concept of intelligent manufacturing in China. I hope that you can use great national projects as a mirror, making zero error a professional instinct.